Once you deployed your apps to need to deploy, in order to make the apps sleep when they're idle, we wanted to know when the apps are being accessed. Consider the following example of an app named SpinCart, which is deployed and running on NeetoDeploy. Whenever a user enters the URL for their app in the browser, this request first hits our load balancer. The load balancer has different ingress rules defined for all the apps, which describes how requests to different hosts should be routed to the different deployments. In this case, we have an ingress rule that maps the URL spincard.neetodeployapp.com to our app's deployment. So whenever a user hits the URL for our app in the browser, this request is first caught by the load balancer and it is then routed to the corresponding deployment in our Kubernetes cluster. We decided to mark the apps as idle when they are not accessed for more than 5 minutes. If you don't use your app for 5 minutes, they will be scaled down and would be brought back up when you hit them again. For calculating this and to do the actual scaling down of the deployment, we created a new microservice aptly called the pod idling service. The pod idling service has a Redis cache where it will store information of when each deployment was accessed the last time. We were using Traffic as our load balancer and we implemented this using Traffic's custom middleware. We wrote a middleware that would intercept every request and send the information to the pod idling service. The pod idling service would then store the name of the deployment along with the timestamp the request was made in this Redis cache. So at any given point of time, the pod idling service can look at the list of apps in its cache and figure out which all apps have not been accessed for the last 5 minutes. The pod idling service has a cron job running every 5 minutes that would then scale all of these apps down. It will also delete all the resources related to the app, like its ingress rule and the Kubernetes service. This way, we can make sure that no app is running for more than 5 minutes and that they are made to sleep when they're idle. Sleeping apps when they're idle doesn't work unless we can reliably boot them up when they're accessed again. We created another microservice called the downtime service, which would bring up the app if it is being hit when it's idle. For this microservice, we created a wildcard ingress rule with a lower priority. So any request for a hostname that doesn't have its own ingress rule would be captured and sent to the downtime service. If your app has been scaled down by the pod idling service, it would also have deleted your app's ingress route. So the next time you try to access it after the app is sleeping, the request would instead be routed to the downtime service. The downtime service then checks the cluster if the deployment you're trying to access already exists in the cluster. If yes, it sends a request to the cluster to scale the deployment back up again. The downtime service then waits until the deployment is up and running, and in the meantime, it would redirect the user to the same URL until the app is up and running. Once the app is up, the Kubernetes service and the corresponding ingress rule are created. The downtime service would do one final redirect, and since we have got the ingress rule now, the request would be routed to the deployment that just got scaled up. From the user's point of view, once the app is idle, it takes a couple of extra seconds for the app to load the first time when they're trying to access it again. This has been a quick rundown of how we architected the sleep when idle feature in NeetoDeploy.